Morning, everybody, or day, or wherever you are. How do you do? This is Tom, back in the Foundry again. This is a follow-up on the gating systems part 3. Now, where you watched me, you didn't watch me design it and all that. I did design it and used the gating systems formula, you might call it, that somebody devised and the Navy adopted. I'd like to say the Navy devised it, but who knows. Anyway, somebody devised it and the Navy adopted this system. Here was the pattern. You know, this was the end gate, and I wanted the maximum that I could possibly have as an end gate. Okay, not entirely sure if I'm letting you see this real nice. Anyway, it's only about a 1/4 inch tall and about 2.25 inches wide. Okay, using the formula, I worked backwards to figure out how many square inches that had to be. Okay, figured out how many square inches that had to be by the formula, how many square inches that had to be by the formula. And then after all that was done and over with, using the formula, figured out how big this down sprue, the sprue, had to be. And it turned out that's how big the down sprues had to be. Now, if you've ever watched any of the other guys that do any molding and casting, you see them pouring their metal down sprues that are practically as big around as the head of this hammer. Okay, now I have a suspicion that they think that if they just put a down sprue in between whatever they're casting, and that acts as a core, I mean not a core, but a riser. I mean, it would act as a riser if you had good contact in the mold cavity here and here, if there was 2 castings, let's say, and this was close enough to act as a riser. Sure, that would be good. Problem is, when you pour it down, this one I saw. He had 2 castings, something about this big around, maybe even slightly larger, in the middle, and 2 end gates that went directly into the casting, the mold cavities. And he poured it down here, and they looked solid enough. Problem is, every little bit of the dross that is formed in here, when it falls from a great height, hits the bottom, churns, and you know, continues to churn as this is filled up, because it's not tapered at all. That junk, that dross, will go into your mold cavities and become part of your casting. It's especially bad if the casting is going to be something that has any kind of pressure whatsoever on it, whether it be pressure from, you know, tension, compression, torsion, or any of those other types of pressures that are exerted on castings, or if it's part of a pressure, you know, like let's say it keeps pressure from coming out of, let's say, a steam engine. Okay, you want to have 100% solid metal from top to bottom, side to side, if you're trying to maintain a pressure environment, a pressurized environment. Okay, if you don't have 100%, you're going to take your chances on whether or not something like steam might work its way through the casting and blow out and possibly hurt somebody, which would be very bad. Okay, and that's the reason why it's bad to have something this big. Now, it goes against all of my instincts to trust something this big. My instincts are saying, no way can that stuff go through there, fill up an entire mold cavity. You know, that's instinctual. Well, I've had that instinct challenge before back in the late 70s when I was a student at Mulder Journeyman School. And the first time I made something that was like this, I just said nah, because I'd been in the Navy six years about that point, and had been a molder at least 5 years at that point, and all we ever used was something about this big, maybe something slightly smaller than that, but on average it was something this big. And they, most often than not, they were all tapered. Okay, I don't remember using a straight shot very often, but as soon as I went through the class and saw how valuable it was for a tapered sprue, I never bought another one, another straight one, that is. Okay, but this you know, it takes a lot of effort to make a mold. All right, it's not one of those 3-minute jobs you can just slap together. You got a lot of things to consider, because you're trying to make the best casting you could possibly make, not just the prettiest casting, but as in the case of a steam casting, you got to make the best casting you can possibly make. Okay, and for something that's going to hold back the pressure of steam, that if it fails and it hurts somebody, you know, you got to keep that in mind all the time. All right. So I went through the class and kept all my notes, and using those notes made this and this, rammed it up as you saw in Gating Systems Part 3. And yesterday I went and poured it, as you can see here. Okay, now ignore this hole, because that hole was just an experiment. That hole happened after I got this all done. You, as a molder, no matter how much time and effort you take to make the very best mold you can, so that the very best casting can be generated, you always have this little bit of doubt in your mind. You know, what went wrong? Because things can go wrong. No matter what, you can follow point A to point B or point Z. Something happens, okay? You know, and it's only after something happens that you can look at it and say, oh, I forgot to do that, or oh, you know, it went wrong. But I was waiting. Well, I spent all day yesterday, I did this first. Okay, got that done first, because I've been waiting for a while. And I'm sorry this has taken so long to get another video out. I had a grand time at my baby sister's surprise wedding. As you might have seen it posted on my site. This was for all the people. That was for anybody who wanted to watch it, of course, but that was posted specifically for all the people that couldn't make it to my baby sister's surprise wedding. And the one who was holding the surprise was my baby sister. Now, she had met this fellow, Dan Beerley, and they had fallen in love, and they had gotten married in a legal marriage, but they had gotten married in a small setting, a small ceremony, okay? And ever since then, Dan had been telling Kendra, my baby sister, he wishes he could have had a good big marriage. You know, obviously he was wishing that he could have had one for her, but this had put a little bit of thought in her mind, and after 8 months or so like that, she had it all set up and had a surprise wedding for Dan. Okay, it went perfectly. Okay, I had a ball. My wife had a grand time. You know, we watched everything happen. And if you're interested, I'm not going to take that video off for another week or so. You can watch it. And the only thing that went wrong on this entire thing is that I totally forgot about the songs that were being played, and how some of them might have a patent pending, or what is it, copyright on it. Totally forgot about that. And although I don't know what I could have done, and still taken, you know, video of it, and I suppose maybe I need to figure out how to zero out some of the songs Anyway, and YouTube kind of gave me a little slap on the wrist and said, you're not supposed to do that. And thank you, YouTube, for not slamming me bad. But it was my first time, and I totally forgot about it. I'm sorry. But I immediately after that message, I took the monetization off of it. So if there was any money to be made from it, it wasn't going to be. I wasn't going to be the one to make it. Okay, because I mean, my mistake, right? And by the way, the words "my mistake" are still in the English language. They haven't been totally replaced by the foolish phrase "my bad." What does that mean? Okay, my bad is not the same as admitting it was your mistake. I don't know. Didn't invent it, don't care. Just think it's a stupid saying, and it, you know, just you jump over the fact that you're admitting it was your mistake. But let's go back to something here. After I got back from the wedding, we had a ball. It took about a week for us to go up, have the wedding. We stopped by Biloxi, where the gambling casinos are, and then finally made our way back home. Okay, then this was waiting for me. Okay, and it had been sitting for a whole week. Okay, now up here it's dry as a bone, but believe it or not, inside it still was moist. Okay, I didn't expect that. Being in the Foundry in the Navy and using Petrobond sand all the time, we never had to worry about things drying out and having to put more water in it. The only time we ever had to add anything to the sand is when we had a whole lot of castings that we made, and you know, the little bit of that surface, actually the part that the molten metal rests on, that oil inside there, and I think a little bit of the clay in the Petrobond powder gets burned up, and you know, it adds up after a while, and your sand, no matter how many times you mull it, starts behaving badly. It doesn't behave like it should. So, you know, that's the only time we ever had to add anything, and usually that was just a little bit of oil we would add to compensate for the dusty sand that was in there. So anyway, yesterday I set up the furnace. Got 3 or 4 pieces of ingots, 3 or 4 ingots. Put it in the bottom of the steel crucible that I had, and then filled it the rest of the way with crushed cans, soda cans. 99% of which my wife drinks. Oh boy! And I mean, we had a 55-gallon drum. Let me point that over there. That 55-gallon drum was absolutely full of crushed cans, okay? And we had some waiting for me to dump into that inside the house. I had to do something, all right? So, let me aim you down just a bit. So, yesterday I made up my mind not to play on the computer anymore, to get out here and get something done for the videos. And I went out, poured some metal, and this is it. And always with a little bit of trepidation, I open a mold, and you're going to see it for the first time. Now, if this don't work, if for instance for some reason my math was wrong, and by the way, the fellow that pointed out, a fellow or lady, I can't remember, who pointed out that my math was wrong in a certain spot. Okay, I found that. I corrected it. Okay, but I never have 100% confidence in my math. Never did like math all that much, but when I have to do it, I usually have to do it 2 or 3 times. I got my associate's degree in mechanical engineering, and I must have gone over the same equations that other guys would have done 3 or 4 times just to make sure I was right. So, lack of confidence makes you work harder, I suppose. Now, I'm going to open this up, and we will see if it works. If it doesn't work, this video, the one I'm shooting right now, will not see the light of day. No, I'll show you in a minute. But that's what I said to myself when I first started thinking about opening this up. All right, let's see how it goes. Pardon my back. I don't want, oh, by the way, new device here. I found out, instead of having this dump on the floor and me putting it into buckets, I found out that this fit underneath this. So I'll be able to dump this into this when I'm done with it, and I'll be able to take this and either store it in the molding bench or use it, you know, when I'm making a mold, because it's plastic. It's not going to rust from the moisture, and it's solid, so it's not going to go all over the floor. And got this at General, what the hell is that place name? General Instruments? Let's see. No, I can't remember. Anyway, it's one of those places where you can buy a lot of tools, and they got good products. Just darn it, can't remember the name of it off the top of my head. Anyway, got this. Got it originally just to do work in the backyard, but when I tested it under this, it worked perfectly. Okay, so if you're going to get one of these, I highly suggest you get one of these so that you know you don't have it all over the floor. Okay, in this place it's a floor, not deck. Now, gonna open this up, and again, pardon my back. Let's see if I can get this baby open. And drum roll, please. Hey, look at that! It absolutely did work. All right, let's see if I can tap this into submission. I want to keep it in one form so that we can look at it. All right, always remember, hot or cold, don't smash your casting with a hammer, because the casting might be very sensitive. All right. Despite my not having a parameter, must have been very, very freaking hot. Because look how it also, when I poured it, it also went down a vent hole. Okay. A couple of little holes I put down at the end of the casting so the gas would absolutely make it out. You can see here, just tiny little, I think it was just part of a steel hanger, coat hanger. And here's how, this time I made certain I got it in the middle. Okay, but the reason why I know it was plenty hot, look at the shrinkage here. Now remember that one casting that we saw in the risers video where somebody was trying to make, I don't know, some kind of a cross type of setup, and you had some deep shrinks on the back side? Okay, notice on this side no shrinks. That's because the metal came down here. I made sure I poured onto that there. It fell in there, filled this up, flowed across there. When that filled up, it finally went through here and filled this casting mold cavity up. Okay, now you can see this will be the thickest portion. Now if I was worried about shrinkage on this, I'd be mad at myself because there's a slight divot right there. I don't know, let's see, I'm going to use a straight edge, this little straight edge right here, and I think you can see a little depression. Now, if this was supposed to be a solid back, I'd have to do this over again, okay? But then, if I was a regular Navy Foundry, I would have had a pyrometer, and I would have known that this was, well, this would have been too hot. But I wouldn't have gotten up to this point in a Navy Foundry that always had a pyrometer, okay? A pyrometer, to those who don't know, it's basically a temperature taker, okay? It's designed to be immersed in molten metal, not to be destroyed by it, and tell you how hot your metal is so that you can take it out at the right point. All right? And this was the thickest portion right here. All right? And look at that. Nice. And let's see if I can get it. A nice deep hole where the shrinkage took place. All right? So this only had a little bit of a dip because, well, this had a dip too, a couple of them. So once this filled up, it froze up and shrunk right there. If I'd had another time to do this and it had to have a back on it, a nice solid back, I probably would have made this ingate like, well, can't see the curvature. Anyway, a little bit closer, so that this might have acted as a small riser feeding that. This would have froze first. This should have been frozen second. This would have been frozen last. That would have been next to last. That would have been frozen last. Now, the reason why this didn't freeze up and stop and short pour on me is because all the metal that went through that was always moving, okay? It never stopped, all right? That's why you never stop when you're pouring until it backs up on you a little bit. Then you know everything is about as far as it'll ever go. If I was to stop the first time that backed up on me, this would have paused. All four of these edges right here would have instantly froze this portion, and then it would have filled up, and whatever was filled in here, that's all it would have been, is just that full. Maybe it would have gone as far as out to here and never made it to this ingate. All right, don't have any idea. But this system works, okay? Just get yourself a pyrometer so you know not to overheat your metal. This would still work, okay? For what it's designed for, if I was to use it. All right, but if you poured it, like you see, the pouring temperature for aluminum in the Navy, I don't know where, if any other foundry does this, but is 1250 degrees to 1400 degrees, okay? That's the range in which you pour it. The thinner the piece, like this would have been considered kind of a thin piece, you need to have it at 1450 degrees. The thicker the piece, if your casting was like that, all right, 1250 degrees. That's all it would have needed, all right? So that worked perfectly because of the system set up and adopted by the Navy. So if you had any doubts in your mind whatsoever, if you tried to start making one of these using that formula and found this to be unreasonably small, it's not. It's not unreasonably small. It worked. It worked every time. Okay, back when I first learned this system, it worked, even though it was like small like this, and it worked yesterday. Okay, have faith, follow the formulas and the calculations, and you'll find that you won't be screwing up as much as you would have if you didn't. All right, please don't put a down sprue the size of your hammer head. Yeah, it'll act as a riser, but you'll be solidifying a casting that has a bunch of dross in it. Okay, now item number 2. you always got to, pardon my back again, you always got to figure out a way to make the pouring basins, okay? And sometimes you can make them easier. You can make something, or you can devise something. Most of the time, if you don't do this, you're going to be doing it by hand tools, and that takes a lot of practice, and that takes more time. Now, when I was in the Navy, we had something that one of our guys saw and they bought. There was a platform about so big around, okay, but it was just a single piece of sheet metal, about that round. It had a handle on it, just a wooden handle. I don't have anything nearby that could substitute for it, but pretend you had a round wooden handle on it like that. And then on the bottom side of this, you had some what looked like guitar wires or maybe piano wires. Okay, you had a shank, you had a shaft that was about so long, attached to the middle of the sheet metal and where the handle was. I think the shaft had the screws on the end of it, so you could tighten on the handle on it. Okay, so you have a piece of plate, handle, shaft. Now in the sheet metal, you had a bunch of holes that was drilled into it, and on the end of the shaft, you had some slots, cut into it, so that you wove the metal through the hole, went across the slot, went through, and eventually you had a conically shaped piece that would do just about what this is going to do. Now, I'm almost always in the kitchen section. No, it's not a joke. I'm almost always in the kitchen section of the whatever store the wife is in at the time, just to see if there's anything interesting that might help with ramming up, okay? And I finally found something. Now this is supposed to be, once you take the pit out of an avocado, what you're supposed to do is you're supposed to take this, bury it in it, go a few times, pull it out, and the majority of the avocado comes out with it, okay? And I saw this shape and I said, well, pretty strong. Let's see if this will work on a mold. Now let's pretend that this is the coat, okay? You just take this, wherever you wanted to have your sprue, and you can either continue to twist it, or you can go back and forth, whichever's easier in your particular stand. All right. Now that made a nice shape in there, and the whole purpose of this is to make a pouring basin that you can easily put your pour your metal into, right? Well, once you get this out, you blow it out or you dump it out, you take your sprue, make sure it's straight up and down, and push it in there. Okay, pull it out. Now you have a pouring basin that you can hit almost anywhere on the side over here. It directs the metal using the curvature you formed, and down to the tapered end of the sprue. Now, I would, after I got this all formed, go around with a brush with some parting powder and make sure all the loose sand, because there is loose sand in here, and any sharp edges that were formed in here was taken care of. But there you have your pouring basin. Now I'm going to try and get you closer so that you can see it a little bit better. Okay. Let's see. Okay. Now, any place else, you can go to any of those places, and you can utilize those devices. Go on the back side and show you what it looks like. Yeah. Well, I would have had that cleaned up. This was holding it up in the air, and the reason why that busted out like that, as you can see right there, is because this was not backed up by this board I had it sitting on. This was up in the air a little bit. So it just goes to prove you got to have boards on the back side of these so that you can, or on each side when you're working on them, so that when you push like the sprue through, it won't bust through, okay, if that's the case. That would have been a nice neat little hole and would have represented an easy way for you to pour the metal, okay. So now, in the near future, I've got that, but I haven't, because of my having made this, and most of the stuff that I've been making so far has just been small enough that all I have to do is just cut an angle. See, that's where the over there, that's where the metal came in contact with the wood, and it's showing right here. But I didn't make this huge. All I made it is just big enough to where you could pour, hit this face, have it go down, and basically you just have this little area here where it's falling and going with the opening, and so you minimize any dross that you might be forming. Now, dross, you don't see a lot of it in aluminum. You don't see, because aluminum doesn't combine, with the atmosphere in there as easily. But it's really, really important to make sure that you follow this when it comes to any copper alloy, because copper is so bad in absorbing hydrogen. I mean, if you try and pour copper all by itself, and if you don't try to pour it in a vacuum type of atmosphere, you're going to have a billion little holes. And I don't mean the kind that you can see readily. Sometimes you can see them if it's a very, very rough pour. But, if you're trying to pour something like electrical bar, you're going to have a bunch of little tiny holes in it, which would cause a lot more resistance in that bar and a lot more heat, and eventually that bar would fail because of the overheating. All right, so that system that this highlighted and is now in your own, using your own eyes, can prove that it works. That system works, okay? Especially important with brass and bronze and copper alloys. All right. Anyway, this was just a short one this time, because I just wanted to see if it came out myself and to show you if it did come out. All right. If there's anybody out there that's not sure about doing this, just go over it again and look at this picture, and you'll see that it absolutely works. All right. Just try and sit through what appears to be a very long video and learn as much as you can. Our I don't know, what was it? I think it was 16 weeks our school was. All right. I mean, the A school, the minimum school, 16 weeks. So I haven't made, shoot, I've only made eight videos so far. I've hit the hardest, the most important subjects so far, and this one is a very important subject too. So Gonna kill the, I'm not kill, but turn off the camera now. Gonna take this, put it through my minor molar. Hey, that's pretty good. Anyway, a mixer, get it molded up, and stow the sand again, and get this put online. All right, my plan for my next video, my plan is to cover cores. Okay, now as is usual, all the best laid plans of might and men often go awry. So it might not be for 1 or 2 times, depending, but that's my intention. Okay, so if you're enjoying these videos at all, if you're getting some information out of them that you didn't know before, great. That was my entire concept behind my making these videos. And if spread the word to any of those guys and gals out there that are pouring, all right, making molds and pouring. I won't steer you wrong on the information. There are those out there, the guys and gals who absolutely taught us, the instructors. They would make a better video, I'm sure, because they've got, all that training behind them on how to train other people. I was just a chief molder, and I never went through any classes that was for teaching. So I'm doing my very best. But please spread the word for the people to see them. If they like them, have them, subscribe to them, to the channel, and we'll have some more interesting stuff being made. I've hit almost, most of the theory that is for the guys in the backyard pouring. I'm not going to hit a bunch of heavy-duty metallurgy. I'll illustrate some points, but I'm not going to go and tell you, how to mix metals and what the order in which the metals you pour it together and all that good stuff, because not everybody has base metals. Not everybody has copper, not everybody has ferromanganese, ferroaluminum, ferrosilicon, chromium, and all that good stuff to be able to make your own alloys. Most everybody is getting the stuff that they pour from scrap. So I'm trying to teach those guys and gals that are getting their metal through scrap how to make the best use of their molding, materials and their foundry furnaces, and put that stuff together. So, okay, well, this is the end of it. So please subscribe. Please press like if you like. If you press don't like, or unlike, or whatever it was, or dislike, do me the courtesy of writing a little comment and telling me what it is you didn't like, and I will make every effort to correct anything that's was wrong. All right, so to everybody out there, have a good molding experience, and to all you retired molders, a Liberty Call.